You're using Databricks wrong. Are you still writing clunky, over-engineered code to do simple things? If you're pulling secrets with 15 lines of Azure SDK boilerplate, digging through storage accounts manually, or hard-coding client names into your notebooks, I've got bad news. You're not being clever. You're handing attackers the keys to your data warehouse. Today, I'm going to show you exactly how to use DB utilities the way it was meant to be used, real-world failures, battle-tested patterns, and how to avoid fatal mistakes that waste your time and kill your career. This isn't a syntax walkthrough, it's a field manual. Let's go. Databricks Utilities, DB Utils, is your built-in toolkit for doing all the glue work that devs try to duct tape together with Python scripts and wishful thinking. File system access, secret management, notebook chaining, runtime parameters, job value passing. Most teams wield only 10% of this power. Today, we maximize that. Let's talk file access. Real world problem here. You're trying to debug a failed ingestion, and your only insight is a timeout error and a blob path. Now you're in Azure Storage Explorer, praying that it doesn't crash while loading a million files. Here's the DB Utilities fix. Here, we're looking at dbutilities.fs.ls, looking at our mounted directory here. That's 5 seconds to inspect the folder without leaving your notebook. Pro tip here, use this in your pipeline to generate automated file logs that don't rely on manual checks. And that would look something like this. Now you've got a traceable audit log every time the pipeline runs. All right, let's talk widgets and runtime parameters. If you've got 5 notebooks doing the exact same thing with different client names, you don't have a pipeline. You have a copy-paste circus. Here's the DB Utilities fix. So DB Utilities has a widgets.txt. This creates the widget. And then you have the DB Utilities widgets.get, which retrieves the value of that widget. So don't over-engineer your widgets though. Too much logic here is being built around them makes notebooks fragile and non-portable. Use them for simple flags, nothing more. Let's look at notebook chaining. This is where some of the real power of Databricks and Spark are. One team I helped had a 2,000 line notebook that ran the entire pipeline. When it failed halfway through, they had to rerun the whole thing every single time. Do you have any idea how much that costs in time, in compute, in engineer morale? Split your logic into modular stages. So something like this. We could actually run one notebook from another notebook, right? Using this dbutilities.notebook.run. If the tasks are independent, run them in parallel. So you could use the concurrent futures and actually run these notebooks in parallel all at the same time, and that code would look something like this. All right, let's talk about passing states between different tasks and notebooks. If you're calculating a file path or a start date in one notebook and hard coding it again in the next, you're not chaining. You're duplicating the logic and doubling your failure points. So use code that looks something like this. The DB Utilities has a jobs.taskvalues.set where you could set your task value. And obviously you could set this dynamically with some variables that are being calculated in your orchestrator notebook. And so it might look something like this. So pro tip here, use this when you want lightweight value sharing. Don't persist the files or tables unless you have to. Let's talk about securing configurations the right way with managing your secrets. Real world problem here, a dev hard-coded a password, I've seen this time and time again, in a cell for testing. That notebook ended up being saved into Git, and it was a public repo, and it was still active. I've seen it, I fixed it. This is not fun. Nobody wants to have some type of security breach here. So utilize your key vault if you're in Azure, and utilize this particular DB utilities function to retrieve those secrets. It's simple. You don't have to use that whole Python library. That you don't have to use that whole Azure library to go through and write a bunch of lines of code in order to retrieve one secret. It's very simple. dbutilities.secrets.get. You put in the scope and then the key. The scope being the actual key vault that it lives in, and then the key being your secret. So secrets are masked in the notebook output, which is amazing, right? It'll show just a redacted, and it won't actually print out if you try to print it. However, they can still be exposed if you try to log or cast a string or do some type of export. So be sure that you parameterize your secret scope and your key and make it environment aware so that it will easily be changed as you promote your notebook from dev to test to production. That code looks something like this. So here we're using some widgets to retrieve the environment, and then we're using an if statement to determine which of the secrets that we're getting depending on which environment that we're in. Pair this with some consistent secret naming across your environments so that if dev uses db.password and prod uses SQL you're asking for a 2 a.m. outage. Don't do that. Make sure you're using consistent naming standards across all of your environments. Here are some real project examples. This particular one is a manufacturing domain, so bear with me. A manufacturing client was processing some sensor and performance data across dozens of machines on multiple production lines. Each production line had its own cloned notebook. The only difference between them? Folder paths and secret scopes. When something failed, a dev had to SSH into a drop folder, manually download a log, and then Slack a screenshot to QA for them to troubleshoot. The fix here, we refactored the pipeline using the DB utilities functions, using widgets to pass in the machine ID and the production date, using secrets.get with environment-aware scoping, using notebook.run to modularize ingestion, QA, and transform. Then we have task values that we were using to pass the thresholds and timestamps between notebooks. And then we have the list object to archive and log your incoming files. So the result here, 80% fewer support tickets, 35% faster runtime, and full audit readiness across their environment. Here are some common pitfalls. Secrets are masked in your output, but they are not in your logs, strings, or exports. Don't assume safety just because the UI is hiding it. Widgets do not equal orchestration. If you're branching logic off of 4 inputs in one notebook, stop. You need workflows, you need Airflow, you need ADF, you need something to help you orchestrate that. Especially with the new jobs task in ADF, that could be a good use case for that. Okay, DB Utilities has a fs.rm. This is a landmine. One time I saw dev delete a full mount point by passing in the wrong folder. No confirmation, no recovery. It was terrifying. Luckily, there is some time travel in Delta, and so you could go back and retrieve the data as long as you have it turned on, and I wouldn't do it real often. You never know when something's going to hiccup. If this saved you one mistake, 1 hour, or one ticket to hell, and if you're still copying and pasting Azure SDK code into your notebooks, I'm not mad. I'm disappointed. Databricks gives you power. DB Utilities tells me whether you actually know how to wield that power. And if you want to know the top 10 Databricks mistakes that you're making right now, check out this video next, and don't make your platform be the bottleneck. Drop your worst Databricks horror story down in the comments. I'll feature the best ones in a future episode, or maybe even bring you on live to break it down together and talk about a full postmortem and what you would do differently in the future.